Hello everyone. So in this video we will be deploying the custom subgraph. So before diving into it, first we will understand what is Rootstock. So Rootstock is a groundbreaking platform that serves as the first and most enduring Bitcoin sidechain. It is designed to combine the robust security of Bitcoin proof of work consensus mechanism with the flexibility and programmability of the Ethereum smart contract capabilities. So this unique integration bridges two of the most powerful blockchain ecosystem, offering the best of both worlds. So Rootstock operates as a layer 2 solution for Bitcoin, meaning it extends the functionality of the Bitcoin blockchain without compromising its foundational security. By leveraging Bitcoin's hashing power, Rootstock ensures a high degree of decentralization and resilience, with more than 60% of Bitcoin miners currently participating in its network through merged mining. This level of adoption make Rootstock one of the most secure smart contract platform in existence. So the platform is fully open source and compatible with the Ethereum Virtual Machine (EVM), enabling developers to deploy Ethereum-based decentralized application directly on the Rootstock with minimal adjustments. This compatibility supports a wide range of use cases, including decentralized finance, non-fungible tokens, NFTs, supply chain tracking, and beyond. So Rootstock's evolving ecosystem is designed to become entirely trustless, removing the need for intermediaries and custodians. So this ensures that users retain complete control over the digital assets, aligning with the core principles of blockchain technology as a gateway to innovate and secure dApps. Rootstock is not only expanding Bitcoin's utility but also pushing the boundaries of what blockchain technology can achieve. So now we will understand what is the graph. So the graph is the decentralized protocol that helps index and query data from the blockchain. So with the help of the graph, it is possible to query data that is often difficult for user to access directly. Any Ethereum data can be searched through simple queries using the graph. Now also Solana can be queried. Why was the graph protocol important in the first place? So DeFi and NFT services like Uniswap and Bored App Yacht Club store data on the Ethereum blockchain, which is difficult to read and query. So Bored App Yacht Club has information such as product and other important information available. So this is because they are programmed into smart contracts after all. But the smart contracts are not enough for advanced query like aggregation, search, and filtering between specific holding addresses. So to access this data, we need to process every issue ever released and read metadata from IPFS, which is interplanetary file system, using token ID and IPFS hash. Moreover, the process takes hours or even days to finally get data we need. So the graph protocol solves this problem by decentralizing the query and API subgraph layer. So we don't have to dig so deeply into the information we need. So graph has multiple products. So first we will be seeing the subgraphs. So this subgraph is a custom API constructed on blockchain data. So subgraphs are queried with the use of GraphQL language and are deployed to the graph node using the graph CLI. Once deployed and published to the graph decentralized network, indexer method subgraphs can cause them to be available to be queried by using subgraph consumers. So now we will be building a subgraph. So subgraph can be built by using following steps. So first we need to navigate to the Subgraph Studio. So here first we need to sign in. As I already signed in, so it directly get signed. So now we need to create a subgraph. So we will create a subgraph with name as a Rootstock subgraph. So it in real time checked whether this subgraph name is available for me or not. So it is available. So now let's create the subgraph. So as you can see, my subgraph has been successfully created. Here the graph gives us the steps that we need to be followed. First is like once our subgraph is created, then all the commands that will be seen on the right side of the page should be entered in the console of the directory. So first we will select the network as the rootstock. So rootstock, so it's showing rootstock testnet, but we will query the data from the rootstock mainnet. So we will select just the rootstock, not the one with testnet in front of that. So now yes, we got all the queries that we will be requiring install the graph into our local. So first we will create a directory into our local. So let's name it as rootstock graph. Now we need to open it with an ID. So here I am using cursor as my ID. So now we need to simply follow the steps given by the graph protocol. So first we need to install the graph CLI by running one of the following command in your terminal. So they have given all the command with different packages, like with yarn we need to paste this command, with npm we need to use this command, by using pnpm we will be using this command, and if you are using burn, so simply copy paste this command. So here I will be using the command with npm. So the graph CLI is getting installed into my local. So the complete node is getting installed into my local. So it's taking a little bit of time. So as you can see, all the required packages are getting installed. Now we need to initialize the subgraph. So we simply need to paste the command graph init rootstock subgraph, and here we got all the networks to be selected. So as you can see, there are multiple networks. So we will simply select the rootstock by using the down arrow or by simply typing the name. So as you can see, I am selecting the rootstock as my network, and the source to be indexed is like from the smart contract or by using substream. So as in this video we will be discussing about the smart contract, so I will simply select the option of smart contract. Now let's name the slug as rootstock subgraph itself, and we will select this directory as only, so it will initialize all the required code base into the same directory. So now we need to add the contract address. So I will select the reef token contract address. So I will simply search for reef contract address. So as you can see on rootstock official documentation, there is the address for the contract address for the reef token. So I will be simply using the same. So I will be copy pasting the contract address. So it's fetching the ABI from the contract API. Then it is fetching the start block from the contract API. Then it fetched the contract name from the contract API. Now it automatically gives the starting block for the contract. So as you can see, the starting block over here is around 8,92,218. So it's correct. So we will just simply hit the return. If you need to modify it, you can just write the start block from where you need to index the data from the contract. So we will simply hit the enter button over here, and as I already mentioned, the contract address is for the reef token. So it fetched the correct contract name. Now it asked like indexed contract event as entities. So yes, we need to index the contract event as entities. So yeah, you have seen like the subgraph has been successfully generated. So it shows an error while installing. So we can simply navigate to the folder rootstock subgraph and simply do npm install. So while failing dependencies, as you see, like it failed to install dependencies by using yarn. So I simply navigated to the rootstock subgraph folder and did the npm install. So by doing this, it successfully installed all the packages that are mentioned into my dependencies. So currently we are using here the graph protocol GraphQL package and the graph protocol GraphTS package. Now we need to authenticate and deploy. So to do the same, we simply need to copy paste this command and paste it into our directory. So it has deployed, key has been successfully set. Now we need to navigate to the directory by using the command mentioned over the website. Now we need to copy paste the generate and build command. So if you are a Windows user, the and option is not supported to the Windows. So you need to copy paste the graph code gen and graph build as a separate command. And if you are the Mac or Linux user, you need to simply copy paste this command into your terminal. So as I'm a Mac user, I will be copy pasting this command. So as you can see, it has generated the build, the generated and the ABIs folder over here. So here you can see like migrations has been successfully completed. It also loaded the subgraph from the subgraph.yml file, which is this. It also compiled the data source from the build folder. It also compiled the subgraph with its schema. Also it writes the subgraph with the ref token and the schema. The final step is to deploy the subgraph. So now we will be deploying the subgraph. So here we need to specify the version for our deployed subgraph. So currently it is, we will give it as 0.0.1. So it is like compiling the subgraph, it is building the subgraph, but adding file to the IPF. So it is, you can see it has successfully uploaded the subgraph to the IPFS. Build is completed and it also deployed it. We also got the endpoint for our subgraph. So the between number is user ID over here. So we will understand the code structure as of now. So first we will see the schema. So the schema.graphql is like a blueprint of the building. It defines the data structure that the graph will index and make you queryable. It uses GraphQL schema definition language, which is also SDL, which is a human readable syntax for describing the shape of your data. So in our case, it describes the types of data that the subgraph will process from the blockchain and how they will relate to each other. So now we will be seeing the data sources. So also before navigating to the data sources, we will see the schema for the ref token. So it has given the transfer, ownership renounced, and the ownership transferred and approval event, and the transfer one entities. So with their respective data type. So transfer entity has like ID, from, to, value, data, block number, timestamp, transaction has as their own event. So we can customize and these entities by using the graph playground, as you can see. So as of now our subgraph is getting synced. So until now it's 24% synced. So on just navigating, you can also see the current block it is on. So it is on like around 15,67,310 block, and it need to be go until 7,77,21,944. So eventually it will take time and it will end the process until it gets 100%. So if you need to modify the query, you simply need to go on to the GraphQL Explorer, and here from you can modify the type, you can just specify the number from where to index and modify according to your need. Also it has entities like ownership renounced, into which it has like ID, previous number, block timestamp, transaction hash. Also it has entities like ownership transfer, which has like ID, previous owner, new owner, block number. Similarly, it has approval entity and transfer one entity. So now we will be diving into the data sources. So into data sources, like it is a file which is like the project manager coordinating between the blueprint and the construction crew. So it ties together the graph schema.graphql and the mappings into the SRC by specifying like which blockchain event should trigger which handler functions. So in this file, you define the smart contract you want to track on the blockchain, the event in those contracts that you are interested in, and the handler function that should be called when those events are emitted. Here you can also specify the starting block for the subgraph, which is the block from which it should start processing data. So in essence, subgraph.yml file serves as a configuration file that guides the graph node about what data it should be looking for and where to find that data and how to simply process it. So here you can see the data sources like Ethereum blockchain. So name is for the contract is Rootstock, and the network for the same is Rootstock network, and the here you can see the address for the Rift token. So as we can also verify from it here, and it also has the ABI with name as Rift token. It also give us the starting block. Also it has done mapping with the events with version as 0.07. It uses the language as assembly script with entities as transfer, owner, renounced, ownership transferred, approval, and transfer one. As earlier we have seen all these entities into the GraphQL with its structure. It has ABIs with Rift token, which is stored into the path under the ABIs. So in this folder it has all the ABIs for the contract of Rift token. Also it has all the events for the entities like transfer, ownership, renounced, with its parameters to be passed and all its handlers, which is stored into like the src folder into this file rift token. Also it has like folder package.json into which all the scripts dependencies needed for the development along with its version is stored. In the network.json it simply stores the contract address and the starting block and the name of the network from which it need to index the data. The docker compose file is used for the purpose of deployment, which uses all the script related to the deployment is specified over here, as it uses Postgres IPFS for its deployment. So it is already mentioned over here. Git ignore file is the file that is used while we are pushing our code onto some of the repos of Bitbucket, GitHub we can say. So like as here is the file called .env, so it will not push the env file. Also there are node modules, which also means like it will not push the node modules folder onto our repo of GitHub Bitbucket we can say. So it also wrote the tests for the contract. So first we will understand the Rift token .ts file. So this imports all the entities for our contract, and then it based on that it handles the ownership, renounced, the transfer, and all the required entities for our contract. Now we will be seeing the project structure and understanding every most important files into it. So the main folder is like a rootstock subgraph. So this is the root directory of our project. It acts as a container for our subgraph and potentially other related projects. So it contains everything that we need to define, build, test, and deploy a subgraph to the graph protocol, into which the first folder is like ABS. So basically the purpose of this folder and the file into is like it stores ABI, which is like application binary interface files for the smart contract for our subgraph that it will be indexing. So why really do ABI matter? So like ABI describe the structure of the smart contract, their functions, events, and data types. The graph uses this to decode blockchain data and understanding which events to listen for and how to interrupt them. Example like into the Rift token.json contains for the ABI for the Rift token contract, and this file is referenced in our subgraph.yml to get all the subgraph and how to parse the events in this contract. Next is like the docker compose.yml. So it basically defines a state of services using Docker containers for local development and testing. So typical services it offers is like Graph node. So Graph node is the main service that indexes blockchain data and serves the GraphQL API. So it uses IPFS, which stores the subgraph files and metadata. And the next is like Postgres, which is the database backend for the node graph, and how it is used like developer runs docker compose up command to start all the services at once, creating a local environment that closely mimics production. This is essential for testing your subgraph before deploying it publicly. So next one is like into the generated. So the purpose of this folder is it contains code automatically generated by the graph codegens tool, and it contains like script types for our GraphQL schemas and contract APIs. It also has helper functions for interacting with the entities and events. So it is important for the files to provide type safety and auto completion in our mapping code, reducing bugs and improving developer experience. So it is created when we run the command graph code gen or a similar script defining the package.json, and the network.json file simply stores the token name, address, and the starting block for our network, and the src folder contains the TypeScript source code for our subgraph mapping. It also consists of functions that handle blockchain events and update the subgraph store. So the ref token.ts implements logic for processing ref token contract, example transfer, approval, handle ownership transfer. So it works like when an event occurs on blockchain, the graph calls the appropriate handler function in these files, which then creates or updates entities in the store. So inside the test, so it contains test code for our subgraph. So now currently it has two files, the ref token utils.ts and the ref token test.ts. So the first ref token util.ts stores the utility functions to help with testing, example like mock functions for event creation, and the next one is like token ref token test.ts. So it stores test cases for our mapping logic, ensuring our subgraph process events correctly. So why do really testing matters? So subgraph logic can be complex and bugs can lead to incorrect or missing data. So automated test search helps catch issues early and ensure your subgraph behaves as expected. So the tsconfig.json is the configuration file for the TypeScript. So it stores the compiler option, like example target version, module system. It includes the file inclusion, exclusion. It also stores the output directory settings. So it is important for TypeScript code to compile correctly and consistently. So we can now understanding the development workflow. So first we define our model in schema.graphql. Then we configure the subgraph in subgraph.yml. Then we write the mapping logic in the src. Then we generates the type using the graph code gen tools, and it outputs into the generated folder. Then we test our mappings into the test folder. Then we run locally or by all the commands into the docker file, and then we deploy to the network using the configuration file in network. So now we will be looking like what really happens when a blockchain event occurs. So first the transfer event is emitted by the ref token contract on the blockchain. Then the graph node detects the event using the contract address and ABI from the subgraph.yml and ABIs. Then the graph node calls the handler function in src/ref token as specified in the subgraph.yml. Then the handler function processes the event and updates the entities in the store according to the schema.graphql. Then user can query the data using the GraphQL as defined in the schema.graphql. So now we will be simply navigating to our playground. So we simply need to refresh our page. So now you can see it has still indexed just the 23%. Here is the playground where you can write query according to you. So here we need to simply name the query. So what we can just give RSK for as of now. Then into this, it is the history for all the queries we generate. It is this logo consists the documentation for our query, and this is the GraphQL Explorer from where we can simply modify our query. So we can simply show the block number, or from the approval entity we can display the block number. As you can see, when I select, it simply appears in the playground, and I will select the ID. So it simply added ID to it. I will display the owner, spender, transaction hash, value, and to run the query we simply need to press on this button. So as you can see, this is all the data available on my subgraph. So it has successfully showed the data from the transfer entity, and the field it displayed is like id, from, to, value. So these are all the fields that we displayed, and as you can see, like approval renouns don't have any data, so it displays the empty. So I will highly suggest you to let the syncing get complete and then try running and playing with the playground. And endpoint is like from where you get all your necessary data like base url, user id, subgraph slug, deployment id, and the version for your subgraph. Also it gives us the development query url with the version, which is most important when we want to fetch the data for our front end. It also gives the curl request. It also gives the React code to fetch the data. It also gives the Next.js code. Also it gives the Node.js code, and all the queries we can modify, simply modified according to our preferences. So from here we can see the development query URL. From here we can simply create the API key. In this section we can see the log for all our. So as you can see, there are multiple logs displayed over here based on the timing of its syncing. So as you can see, it has shown multiple logs. In the detail section, as we earlier saw, it shows all the commands that we need to initialize and deploy the subgraph into our local. If you need to publish, you simply need to publish on the button. Click on the button, and here we need to adjust the setting based on our preferences. We need to select the network, but like as our subgraph is getting synced, we will do it later on when its progress is 100% completed. So if you face any kind of error, I highly suggest you to go to the Graph website, join their Discord available into the footer section of the website, and ask your doubt under the respective channel. Also you can join the Rootstock Discord available into their website in the footer section and ask your doubt into the respective channel. Also you can navigate to the document section and ask their AI chatbot, so it will answer all your doubts in real time. So thank you everyone, happy coding.